Today our lesson is on page 51. It's called linear plots, and our goal is to create linear plots for recursive sequences. So please get your notes set up, and notice that I forgot a couple of sections. I forgot to put the words in, and if you can find me in class today and tell me what words I'm missing from my notes in the setup, then I'll try to find a small prize, maybe a small piece of candy. So if you remember to get my attention and tell me that, then I'll try to do that, because I'm just noticing right now that I forgot to write something. So on page 51 they start with an example of Arnaldo attending the state fair, and he has to pay $8 to get in and then pay $2 for every ride that he goes on. And so I'm going to stop it right here, and I would like you to make a table that looks just like that, and on the top we're going to put the number of rides, and below that we're going to put the cost that he pays if he rides that number of rides. So we're going to start with 0 and go up to 10. I'm also going to be using my book in this video, and I've noticed at first it doesn't show up very good. So on this first example of me using the book, I'm going to probably fast forward through sections of it. It works better on our examples. So just please ignore the where I show you the book here in just a moment. So number of rides on the top: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I'm going to use the book to find the cost for the number of rides, and I'm using a sticky note, and it doesn't show up very good right here, but it will work better in example 1. But I'm using it to line up and find out what the cost is from the table on page 51, and it turns out the cost is $8 if he doesn't ride any rides at all. And we're going to just keep adding 2. $2 for each ride. So I keep going back to the book and adding $2, and I'm just going to fast forward here and stop at a good point where you can see what's happening. So it turns out that this is a recursive sequence, and we don't have to keep looking back at the book or the plot, because the linear plot, because we started with 8 and that was our start value. We had an operation of add 2 because it cost $2 for each ride, and so we just keep adding $2. So that is just an introduction to a linear plot. The chart that says number of rides on one side and cost along the other on page 51 is a linear plot. This is a table that I made from the linear plot. So let's continue on with example 1, and I'm going to show you a method, and we'll get some sticky notes to you so you can use this method when you're trying to read the linear plots and create recursive sequences. So now I'm on page 52, and I'm going to read the linear plot, example 1a. And I take the sticky note and put it on the first blue point. And that shows me 1. That's where I get the number 1 as my start value. And the reason I put a 0 there is the x value is 0. Now the x value is 1, and my sequence number is 4. I've added 3. So we're kind of adding a little bit to our recursive sequence. My x value is 2. You can see I'm just lining up the right hand side of my sticky note with a 2, going up to the point, and I'm going to back up and stop it right there. So this is the x value of 2. I go up to this point and go over, and that's a 7, because these are counting by 2's. So that's the number that's in my recursive sequence. So this number is going to be a 7. So we are counting the numbers in our recursive sequence. When x is equal to 3, I look over, straight over to the 10. So each time we're adding 3. So the first number in the sequence is still the start value, and we're still performing an operation. So we add 3 each time. You can think of the 0, 1, 2, 3 as how many times we've done the operation. How many times we've added 3 to our start value. And once we get to a good stopping point, and I'll explain that a little bit better. So I have added 3 0 times, and I'm still at my start value. I added 3 1 time, and I'm at 4. I've added 3 2 times. I've added 3 3 times. So this is how many times I've done the operation. Now let's read the recursive sequence from example 1b. So the start value is when x is equal to 0. I haven't done the operation yet, so we're going to start at 7. Then we're going to drop all the way down to 2. So when I've done the operation once, then my sequence is at 2. When I have performed the operation twice, my sequence goes all the way down to -3. So our start value is 7. And the operation that we're performing is to subtract 5. So I'm going to pause it right there for you to catch up. I've gone kind of fast right there, and so try to get caught up. And you can pause this at this point if you need to get caught up, but I'm going to go to the next example. Example 2 is page 53, and I'm going to actually draw the linear plot. So you're going to want a ruler, And this is Jerome's personal best. So it's shot put throws in feet along the side and the number of weeks. And in this example, Jerome throws the shot put for New Bridge High School. I'm on page 53. Coming into the season, his personal best was 42 feet. Each week, his shot put throws increase 5/10 of a foot, or half a foot. So we're creating a linear plot to show that half a foot increase. And we're going to turn this into a recursive sequence. So along the bottom, it's kind of like the x value. It's the number of weeks since the season began. So the first line is 0 weeks. That's the very beginning of the season. And we're going to count by ones, but we're going to start at 40 feet because his record is 42. So we'll start a little bit below his record and then just count by ones. And this is in feet. So at the beginning of the season, his record was 42 feet. And again, the label for the side is shot put record in feet. And these are his best throws. So after 1 week, he threw, his best was 42.5, and each week it went up a half of a foot. So as I go to the right, for each week, I'm just going to go up a half a foot. It makes a straight line. And after 8 weeks, we can see he ended up at 46 feet. Now I'm going to make a table and organize the recursive sequence into a table. The top of the table is going to be his throws, his record, and the bottom of the table will be the number of weeks. So we need enough spots on our table to start at 0 and go all the way to 8 weeks. So I'm going to fill in his personal best, just reading from 0 weeks goes up to 42. At 1 week, then I follow this paper over to here, and that's 42.5. At 2 weeks, that's 2 weeks right there, I look this direction straight over to 43. So that's how you read a linear plot. At 3 weeks, I look over to the throws and it's 43.5. Now I'm noticing a pattern. My start value is 42. As soon as I see a start value and an operation, then I can use that as a shortcut. Start value was 42 and the operation was to add 0.5 each time. So I can use that sequence, recursive sequence, to fill out the rest of my table. And I just want to circle the 46 on the table and the 8 and show where those are on the linear plot. Each of these points is represented in the table. That point is right here. That point is right here. If we go back to the first point, it's right there. There's the start value. So again, this is the start value, and we have done the operation 0 times. We perform the operation once, twice, 3 times, and so on.